And I am going to record what I'm doing here. I'm going to be explaining the odd ones on this worksheet. Hopefully you could follow along. You see, it's really easy. Again, we're so used to distributing one term at a time, and that's exactly what we're going to do. We're going to distribute one term at a time. So we're going to pretend that that 4 is not there, and we're going to distribute m times m is m squared. Let me just get this out of the way, and let me show that work. I like to draw arrows. M times m is m squared, and then m times 1, that's positive 1m. Okay, and then you're going to distribute the positive 4 times m, that's a positive 4m, and positive 4 times 1 is a positive 4. You get it? And of course, after distributive property, always try to combine like terms. And out of these, out of these 4 terms, 1, 2, 3, 4, you could combine the 2 middle ones because they're alike. It's like if you have one of these m's plus 4 or more of those m's, you're going to have a total of 5 of those m's. Now, what about the m squared that's in the front? Just bring it down, m squared. What about the positive 4 at the end? Bring it down, plus 4. And there's your answer. So the linear binomial times the linear binomial gave us a quadratic trinomial. Let's jump to number 3. Once again, I like to draw arrows, so I'm going to distribute the b first. So b, this b right here, times that b right there is what? B squared. B times 4 is what? Plus 4b. And then we distribute the positive 3. Positive 3 times b, positive 3b. Positive 3 times 4, positive 12. Simple. After distributive property, is there any terms that you could combine? The like terms, yeah. There's 4b right there and 3b right there. So that's okay. If you had 4 and you had 3, you have a total of 7. So total of 7 of those b's. One thing to review and really understand that when you're multiplying b times b, exponents change. But when you're adding b's and b's, exponents don't change. Keep that in mind. When you're multiplying b times b, you will get b squared. But when you're adding 4b's plus 3b's, exponents don't change. It's just 7b. What do you do with the b squared? Bring it down. What do you do with the plus 12? Bring it down. There's your final answer. Why is it the final answer? Because you can't combine b squares with b's, and you can't combine 12 with b's, right? You can only do like terms. B squares with b squares, b's with b's, and 12s with 12s, or numbers with numbers. Number 5. Where is 5? There it is. It's too easy. I know it's boring. R times r, r squared. R times negative 2, negative 2r. Positive 1 times r, positive 1r. Positive 1 times negative 2, negative 2. Could you combine anything? Yes, the middle terms, these two guys. What do we get? R squared. When you combine the middle two terms, you get minus 1r, because if you owe 2 and have 1, you're still going to owe 1. And then you have the minus 2 at the very end. And there's your quadratic trinomial answer. Moving on to number 7. Again, we're going to distribute one of them at a time. I'm going to ignore the 1 for now and distribute the 3c. Okay? So 3c times c, that's 3c squared. 3c times negative 2 is negative 6c. And then you move on to the 1, distribute the 1. 1 times c is 1c. 1 times negative 2 is negative 2. Out of those 4 terms, you could combine the 2 middle terms, the like terms, the c's with the c's. So if you owe 6 and have 1, you owe $6, you have $1, you can't completely pay them off. You could pay off the $1, but you still owe 5 of those dollars, 5 of those c's. What about the 3c squared in the front? You can't combine it with anything, so bring it down, 3c squared. What about the minus 2 at the very end? You can't combine it with anything, so just bring it down. And there's your answer, 3c squared plus 5c minus 2. Number 9, finally we get to something a little more fun. Why? Because we actually have a coefficient in front of d, but it's still the same concept. We're going to distribute this d times those 5d's, right? D times 5d. Technically, it's like if you had an invisible 1 right there, and you're saying, okay, the coefficient 1 times the coefficient 5. What's 1 times 5? 5. So you can put a 5, and then what's d times d? D squared, that's right. So 5d squared is your first term, and then distribute that 1d to the negative 4. Again, 1 times negative 4, that's negative 4. And d times, there's no other d's, so just bring that d down. So that's your answer for distributing that 1d into the 5d minus 4. Now that you've distributed the 1d, we're going to now distribute the negative 1. So negative 1 times 5d is negative 5d. Negative 1 times negative 4 is positive 4. And of course, out of these 1, 2, 3, 4 terms, you could combine the two middle terms because those are the only ones that are alike. Remember, you could combine d squares with d squares, d's with d's, and numbers with numbers. And the only thing you could combine here is the d with the d. You owe 4 of them, you owe 5 more. How many do you owe? 9 of those d's. Probably should have done that in green. Minus 9 of those d's. What about the 5d squared in the front? You can't combine it, bring it down. What about the plus 4 at the end? Can't combine it, bring it down. There's your final quadratic trinomial answer. Another one. Let's distribute 3n times n. What do I get? 3n squared. 3n times 3, what do I get? Positive 9n, right? All you do is multiply the number, the coefficient with the coefficient, or the number with the number. 3 times 3 is 9, and then the n with the n, but there is no n over here, so you just bring down that one single n. Now let's distribute the minus 7. Minus 7 times n, minus 7n, minus 7 times 3, minus 21. Out of those 4 terms, you could combine the two middle terms. You have $9, you owe $7. You could pay them off. You will still have 2 left over. Positive 2, not $2, but 2 n's in this case. What about the 3n? Bring it down. 3n squared, that is. And what about the minus 21? Bring it down. There's your answer. 3n squared plus 2n minus 21. Again, distributing one at a time. I want to start with the 3b. 3b times 3b, what's that? 9b squared. Why? Because 3 times 3 is 9, and b times b is b squared. Then distribute 3b times negative 2. What do I get? Minus 6 with a b, with a single b, right? Again, number 3 times number negative 2 gives you the number negative 6. B times, oh, there's no b here, so just bring that single b down. Now let's distribute the positive 3. Positive 3 times 3b, what do I get? Positive 3 times 3 is 9 with a single b. And then positive 3 times negative 2, that's a negative 6. Out of those 4 terms, you could combine the two middle terms. You owe 6, you have 9. You're going to have 3 left over. We're talking about b's. Then bring down the 9b squared, bring down the minus 6, and there's your quadratic trinomial answer. Number 15, we have 4c that we're going to distribute. 4c times 2c. Well, 4 times 2 is what? 8. And then c times c is what? C squared. Okay? And now let's distribute 4c times 1. Oh, it's just 4c plus 4c. Now we've distributed the 4c. Now let's ignore 4c and now distribute the 1. That is a positive 1. 1 times 2c is not going to change it. Stays 2c. 1 times 1 is not going to change it. It's going to stay 1. Out of those 4 terms, what could you combine? The two middle terms, the c's with the c's. So your final answer is going to be 8c squared. You couldn't combine it with anything. And when you actually combined the 4c with 2c, you're going to get a total of 6 of those c's, positive 6c. And of course, the 1, you can't combine it with anything, so just bring it down. And there's your answer, 8c squared plus 6c plus 1. Moving on. Let's distribute 4h times 4h. What do I get? 16h squared. How about 4h times negative 1? Negative 4h. How about negative 2 times 4h? Negative 8h. And how about negative 2 times negative 1? Plus 2. Out of those 4 terms, I could combine the middle terms. That will be a minus 12. If you owe $4 and you owe $8, you're going to owe $12. But we're not talking about dollars. We're talking about h's. What about the 16h squared in the front? You just bring that down. What about the plus 2 at the very end? Just going to bring that down. Can't combine anything else. That's your answer. 16h squared minus 12h plus 2. Moving on. Finally, get to some fun stuff here. Everybody follow along. Number 19. Yes, we're going to distribute one at a time. W times W squared. What do we get? W to the third. Rule 1 of exponents. add the exponents, right? W times 3W. Now, it's kind of like if you had a 1 in front, right? So 1 times 3 is 3. And W times W, what do we get? W squared. Thank you very much. And let's now distribute to the third term. W times -6. Well, that'll just be a -6W. Are you with me? So now that we've distributed the W, we could temporarily, or we could ignore it for a little bit and just distribute now the 4, right? So 4, positive 4 times W squared is positive 4W squared. Positive 4 times 3W, 4 times 3 is 12 with that W. And 4 times -6 is -24. Are you with me? So now we have not 4 terms, we have 1, 2, 3, 4, 5, 6 terms. Out of those 6 terms, what could I combine? How about this? Let's start writing our answer in standard form. The highest exponent term first, W to the third. There are no other W to the thirds to combine it. So that's the first part of my answer, W to the third. But then I move on to my W squares. I have 3 of these W squares, and I have 4 more of those W squares. How many W squares do I have? A total of positive 7 of those W squares. And then I move on to -6W plus 12W. That's going to be a positive 6W. If you owe 6 and you have 12, you're going to pay them off and you still have 6 left over. We're talking about W's here. And at the very end, we have the number -24, which is the constant of this polynomial. You just bring that down. There's your answer for number 19. It's a little bit more fun. But as you could see, there's 6 terms, so it's a lot. Now, there's a way that we could organize our work that makes it a little easier. Let me show you that right here with number 21. And that'll be the last one on this worksheet, the last one on this video that we're doing. So here's another way of doing it. We're still going to distribute the k. K times k squared, what is that? K to the third. K times 3k, what is that? 3k to the second. K times -6, what is that? -6k. Now, when I distribute the positive 4 times k squared. Now, what is positive 4 times k squared? It's positive 4k squared, right? But instead of writing it right here, instead of writing it right there, what I'm going to do is write it underneath the other k squared term. Yeah, that's right. That's good. So plus 4k squared. I wrote it right under. That way, I call this stacking. I don't know if it's even a word, right? Stacking. But I like to stack them and organize them so it'll be a lot easier to combine like terms later. All right, so how about positive 4 times positive 3k? Positive 4 times positive 3k, it's going to be a positive 12k, but write that right here underneath the other k term. And then last but not least, 4 times -6, that's -24, and you just write that at the end. But when you stack them, you have your k squares on top of k squares, k's on top of k's, and it's kind of like linear combinations, right? Where we would combine the lines, the k to the third comes down, the 3 plus 4, that's 7 of those k squares, and you owe 6, you have 12, you're going to have 6 of those k's left over, and the -24 just comes down, and that's your answer. So it's just a question of organizing, and yeah, you know what? It was the same exact question. You're right, same exact question. These had K's, these had W's. It's the same exact thing. But I did do it a different way. Instead of writing it all out from left to right, I stacked them, which you might find useful, especially when you get to multiplying like a trinomial times a trinomial. We don't have any on this worksheet, but you know what? Let me finish off this video by showing you that. So this is a different worksheet. You don't have this in front of you, but this one right here has a lot more interesting type of questions. We have a trinomial times a trinomial, right? So this guy right here, you know what? I think I may have explained this one on a different video. So let me go for a different one. Here we go. This guy right here, a trinomial times a trinomial. So you would start, instead of having 2 terms to distribute, you got 3 terms to distribute. Let's do one at a time. And this is what we're going to do. we're going to stack them so it'll be a little bit more organized. 2x squared times 2x squared is 4x to the power 4. That's right. When you're multiplying, you really add exponents. 2x squared times negative 4. Well, the 2 times negative 4 is negative 8. And the x squared times x is x to the third. So you have a minus 8x to the third. And then we have 2x squared times 3. That'll give us a 6x squared. And we've distributed this first term. Now let's ignore it and distribute the second term. The second term happens to be a negative 2x. And when I distribute it, negative 2x times positive 2x to the second, that'll be a negative 4x to the third. However, instead of writing the negative 4x to the third right there on the side, what I would like to do is write the negative 4x to the third right below the other x to the third. Okay, and then we continue distributing. Negative 2x times negative 4x, that's positive 8x squared. And then continuing negative 2x times 3, that's a negative 6 with an x. Now let's distribute the final one, the minus 3. Minus 3 times 2x squared is a negative 6x squared. And notice that I'm writing it right underneath the other x squared terms. And then negative 3 times negative 4x, that's a positive 12 with an x. And notice that I wrote it right underneath the other x term. And then last but not least, negative 3 times positive 3, it's a negative 9. So when you stack them like this, it makes it a lot easier to get your final answer. First part of my final answer is 4x to the fourth. Second part of my final answer is negative 12x to the third. Why? Because you owe 8, you owe 4, you're going to owe 12 altogether. This third one, well, you have 6 and you owe 6. These guys cancel out, and you would have an 8x left over. So plus 8x squared left over. And then over here, you owe 6, you have 12, you're going to have 6. So plus 6 of those x's. And don't forget about that minus 9 at the very end. That's as hard as it gets. What do you think? Actually, I'm lying. It gets a little bit more fun. Where you have more than one variable. Like, for example, 3a minus b times 2a minus b. It's not harder, but some people get confused when it's more than just x or more than just a. It's two variables. Same process, 3a times 2a. How do we do that? Well, 3 times 2 is 6. And a times a is a squared. No problems, right? Now, when we distribute here, 3a times negative b, imagine or understand that there's really a negative 1 in front of that b. So when you say the coefficient 3 times the coefficient negative 1, what's 3 times negative 1? Negative 3. And then what about, actually, let me do this in red. And then what about when I go a times b? That is exactly that, a times b, just ab, right? A times b is ab, right? Okay. So now let's distribute minus b, that's like a negative 1b times 2a. Well, negative 1 times 2 is negative 2. And of course, b times a is ba, but it's better to write it as ab, alphabetical order. And then negative 1b times negative 1b, that'd be a positive 1b squared. You don't even need to put the 1 in front of the b squared. Out of those four terms, what could you combine? The two middle terms are alike. You got negative 3 of these AB terms with negative 2 of those AB terms. It's like if you owed $3, you owed $2, you're going to owe 5 of those AB terms together. What about the 6a squared in the front? Bring it down. What about the b squared at the end? Just bring it down. And there's your final answer for this question. What do you think? You want to see another one of those or no? Here's a GH term. You guys want to try that one? Yes, please. Okay, let's do this one. So we're going to begin. What is 4g times 2g? Well, 4 times 2 is 8. And g, and g times g is what? So 8g squared. Again, 4 times 2 is 8. G times g, g squared. How about 4g times 3h? Well, what is 4 times 3? 12. So put plus 12. And what is g times h? It's exactly that, gh, right? And alphabetical order, A, B, C, D, F, G, H. Yeah, so GH. G comes first, alphabetical order. So GH. And now you could distribute the positive 3h. Positive 3h times 2g. Well, 3 times 2 is 6. And h times g is hg, but put in alphabetical order gh. And last but not least, 3h times 3h. 3 times 3 is 9. H times h is h squared. What could you combine? The two middle terms. 12 of those GHs with 6 more of those GHs is a total of 18 of those GHs. What about the 8g squared in the front? Bring it down, 8g squared. What about the 9h squared at the end? Bring it down, plus 9h squared. There's your answer. Yay, nay, what the hey? I hope you get it. So we do have an assignment, like the worksheet that you have in front of you. That's great practice, and the answers are on Google Classroom if you want to check that out. And there'll be a video also uploaded. But the actual assignment is on a quizzes assignment that's worth 100 points. So open up Google Classroom and get to that quizzes assignment, and let's get busy.